Hello everyone. I hope all is fine. Welcome to my channel, Learn Computing with Daniel Bullen. With me, Daniel Bullen. It has been a while since I've made my last videos. My apologies. Busy with teaching and tutoring. So now, with exams over, I'm going to be producing videos for the next exam season, which I know is a year away, but now is the time to start revising. Which is why I'm doing these videos ready for the next academic year, such as the May 2019 Paper 1 for the OCR spec for GCSE Computer Science. Yes, so that is basically what I'm doing. So before I go into this video, please remember to click that like and subscribe button, and also share this video far and wide, especially if your fellow mates just need that little bit of extra help. Okay, let's get started, shall we? And yes, you'll be sad to know if you do an OCR, you're out of luck because you cannot use a calculator. It's a pity, but life must go on. I'm not going to go through the la-di-da because the invigilator goes through that. And the total amount of marks is out of 80. And yes, just to rub it in our faces, no calculator can be used for this paper. Yeah, rub it in, why don't OCR? Okay, question 1. Kerry wants to buy a new computer, but she doesn't understand the different parts of a computer do. Okay, so Kerry has heard that the CPU heard of a CPU, but doesn't know actually what it is. So what we need to do for her is complete the sentences by filling in the blanks, which describe the purpose of the CPU. So this one, CPU stands for Central Processing Unit. It is part of the computer that fetches and executes the instructions that will be stored in main memory. The main memory is also called the RAM. The RAM is what they'll accept. Main memory, RAM, it's volatile form of memory. But for this case, all we need to say is main memory. And then the last two, the CPU contains the arithmetic. It's going to be logic unit and also the control unit. So you need the words logic and control in there. Okay? That's literally, so that is literally 5 marks. So what you needed were as follows: central processing unit, instructions, main memory, logic, and control. 5 marks, bosh, in the bag. Next one. Kerry is looking at 2 computers. One has a single core processor and the other has a dual core. So we need to explain why having a dual core processor might not necessarily improve the performance of a computer. So the reason why it won't necessarily improve the computer's performance is because dual core is 2 processors. So that would be for 1 mark. And some processors cannot actually be split. Or some processes cannot actually be split between 2 processors. Okay? An alternative one I would have parallel processing can take place, which means each CPU can execute separate instructions at the same time. Any of these options would be 2 marks. But with something like that, we need the notion that the processors are acting at the same time. Not just, so we can't just say it can run twice as many instructions without the at the same time. If you have at the same time, then you're getting somewhere. If you don't have those 4 immortal words, You're out of luck. Okay. They won't allow cores can be split into tasks. We need to know how that's the case. So you could say cores can be split into tasks, but some processes cannot be split between the two processes. Okay? So we can have multitasking. Okay? So I would just say a parallel processor can take place, meaning that each CPU can execute separate instructions at the same time. 2 marks in a bag, bosh. Next one. One computer has 64 kilobytes of cache, and the other 512 kilobytes of cache. So we need to explain how the cache size affects the performance of the CPU. So if we remember the cache, it's basically a part of the computer that where it stores memory that we can immediately access, rather than the CPU fetching the data from the RAM. So by storing in a cache, it's much quicker than getting it from the RAM. But anyway, so how the cache size can affect the CPU's performance. So the cache will store frequently used instructions that can be accessed faster than accessing the RAM, which is essentially what I've just said. So the cache stores frequently used instructions. That's 1 mark. That can be accessed faster than accessing the RAM. That's another mark. That's 2 marks. Done. So if you were to just define the cache as being fast memory or close to the CPU, you wouldn't actually get a mark. So you would need to say that it can be accessed faster than accessing the instructions from the RAM itself. So that is how more cache can improve the CPU's performance, and less cache will decrease its performance. But the problem is, if you have too much cache, it'll take longer to find the instructions in the cache. Okay? So that is everything on how the cache improves the performance of the CPU. Okay, so now we're on to the next one. Both computers have RAM and ROM. The table will have 5 statements describing RAM and ROM. So you need to tick one or more boxes in each row to identify if the statement describes RAM and or ROM. Stores data. So the RAM and ROM will both store data. RAM is where the memory is volatile. Data will not be lost when the computer is turned off. That's read-only memory. Data is read-only memory. Clues in the name. So in a question like this, find some little clues. So that's your little clue. Read-only memory. Done. And we've got stores currently running data and instructions. A little bit of a clue, but not obvious. It's the RAM. So some of these clues, they're bleeding obvious. Or there's like, oh, let's hide and let's be a little bit more subtle. Some of it is like, hello, I am part of the answer. Just like the data is read-only. Okay, let's go to the next one. Give one difference between RAM and flash memory. There are several differences. RAM is volatile, flash memory is non-volatile. So you might even want to look at the previous question as like a little clue to answer this one. We know RAM is volatile and flash memory is non-volatile. RAM is faster to access, whereas flash memory is slower. RAM will store currently running programs, whereas the flash memory stores files and software. Where RAM can be directly accessed by a processor, the flash data has to go to the RAM before the CPU. But if I was to give one difference, I would say RAM is volatile, flash memory is non-volatile. Job done. They will accept description of volatile or non-volatile. Okay. On to the next question. Kerry has 5 gigabytes of files to transfer from a laptop at work to a new computer. She's been told to buy an external solid-state device to do this. So give one example of a solid-state device. Flash drive. Flash drive's one. You can have solid-state drive or just have SSD. Or you could have USB memory stick, or you can have a memory card. I'll just say solid-state drive, purely because of clues in the name. So you've got solid-state. Instead of saying device, just say drive. Done. If you were to say, you could say USB memory stick. If you just say USB on its own, that's not going to cut the mustard. If you say USB stick or memory stick, you'll still get a mark. If you were to say hard drive, you're not going to get a mark. You need to say solid state drive or flash drive or a memory card. Don't just say hard drive. You could say solid state hard drive, but I would just say solid state drive. Then the next one, we need to identify whether the device given in the previous question is an example of primary or secondary memory. It's secondary. Okay, so this is more of a discuss question. So this is a question that needs planning. So Kerry was originally going to use an optical storage device to transfer her files. So we have to discuss whether an optical or solid state device is the most appropriate media to transfer these files. So we want to consider portability, robustness, capacity, and the cost. So this is a big question. So in a question like this, I would just plan what you're going to type. So what's portability? So we want to talk about optical storage, which is like your CDs. And we want to mention solid state device. So that's what we want to mention. Those are the two we need to mention. So in those, we want to talk about the portability, robustness, capacity, and the cost of each. So I would say both optical and solid state are small in size and can easily be moved between Kerry's home and workplace. So solid state, however, can be smaller and less likely to break. Whereas optical, which is a CD, isn't all that robust and can be easily scratched. So it can be easily scratched while being moved. Or someone drops it. Because it can happen, if you drop it, then that can be damaged. Solid state will have no moving parts. So will unlikely break if it is dropped. So we've mentioned portability and robustness. Capacities. CDs have a small capacity. Okay, so it's got a very small capacity. Small capacity in terms of how much data it can store. So the capacity is dependent on Kerry's files as to whether they are small, like text files, or big, like videos or software files. With, say, text-based documents, a CD may be enough. Required storage. If Kerry wanted to do videos, then a solid state will be more appropriate. So that's capacity. Optical storage is cheap to buy. Whereas solid state can be reused more times due to its durability, so maybe more cost effective in the long run, in the long term. So that is a type of thing they would be looking for. They're looking for the pros and cons of each. So optical storage is cheap to buy, but once the storage is taken, more optical storage has to be bought, which eventually makes it more expensive. Whereas solid state can be reused more times because of its durability, so it might actually be more cost effective. As if you have loads of CDs, that's not going to be cost effective, and it's not going to be so durable, and CDs are not as durable. So what we're looking for here, if you attempt the question and you don't get all of it, on a question like this, my answer like this, you could still get some marks. So you need a thorough knowledge and understanding of a wide range of considerations, where the material is accurate and detailed, and we have to apply our knowledge and understanding directly and consistency to the context. So we have to weigh up both sides, so the good and the bad, with a well-developed line of reasoning which is clear and structured. So if you just get facts down, you could still get some marks. You just won't get all of it. So on a question like this, if you don't know what you're doing, have a go, write the odd facts in relation to that question, because you could still get some marks, which is better than just not touching it at all and getting 0, no point, absolutely nothing, zilch, nada, whatever you want to call it. Okay, next question. The file sizes of Kerry's files are usually displayed in megabytes or gigabytes. So we need to calculate how many megabytes are in 5 gigabytes. So we have to show our working for this one. So, the way we would do it, there's 1024 kilobytes in a megabyte. And we're going to times that by 5. Or what you could even do is you could do 5 times 1000, 5000. Okay? 24 times 5, 120. 5000 plus 120 is going to equal 5120 megabytes. Or alternatively, you could have just left it to 5000 megabytes and you'd still get 2 marks. So it doesn't matter which way you do. 5 times 1000 is 5000 megabytes, leave it there. Or you could do 5 times 1000 is 5000. Then you could add 24 times 5 is 120. And then have 5000 plus 120 is 5120 megabytes. Either way will get you 2 marks. So it doesn't matter which way at all. Okay, that is that for now. Number 2. Xander's tablet computer comes with system software, including an operating system and utility system software. Operating system has file management, so we need to identify 3 ways Xander can make use of the file management facility. Well, he can place his files into folders, he can rename the files, he can move the files. Those 3 ways will get you 3 marks. He can open them. That'd be another one. Sort files, that's another one. Create files, another one. Search for them, another one. Set permissions, another one. Delete them, copy them. Basically, all the simple things we do every day. But if you're really unsure about a question like this, think about what you do every day. Every day we name files, open them, search them. Bish, bash, bosh, done. Next one. Utility system software provides compression software. Xander uses this to compress an image. So we need to explain how compression software will compress the image file. So it's going to use an algorithm to remove repeated data. And it could be either lossy or lossless. And it will reduce, and the ultimate aim is to reduce the number of pixels. If you wanted to go down a lossy route, which compression types, you could say we could use lossy or lossless, where lossless will not remove the data permanently, whereas lossy is permanent deletion, meaning the original file will not be restored. 4 marks in the back. Nice little list. Give 2 names to 2 other types of utility software. Encryption, defragmentation. What do we do every day? We back up stuff every day. We could also have auto-update, disk formatting, antivirus. On a question like this, think about what we have every day. We back up stuff every day, and what we're getting more and more, we have to do encryption. Like take WhatsApp, we use that every day, that's encrypted. So you could say antivirus, and you could say encryption software are 2 types of utility system software. Job done. Xander uses a smartwatch. We tick 1 box on whether a smartwatch or a laptop is an example of an embedded system. A smartwatch is, laptop is not. Because an embedded system is just doing one or a very, very tiny amount of very specific functions. So a smartwatch is an embedded system, laptops are not. And for 2 marks, we need to say, well, why smartwatch? Because a smartwatch is not general purpose, and it's a computer system that is built in within the watch. So think about the characteristics of an embedded system. So it's not general purpose, so a smartwatch is not general purpose. So a smartwatch has limited functions. Like any embedded system will have limited functions. 2 marks in a bag, done. Right. Confidential documents Hamish stores on a laptop. Needs his computer to be secure from unauthorized access when connected to a network. So describe the problems that can arise from unauthorized access on his laptop and confidential documents. Malware could be put on a computer for a start. We don't want those. And if he's working with sensitive data, data protection legislation states that personal data has to be protected. And the problem that could arise would be breaking data protection legislation, meaning breach of privacy. So you could say, malware could be put on a computer, the data could be changed, and the files could be stolen. 3 marks in a bag. So I would say, I would go down the data protection where we're breaking data protection legislation and there's a breach of privacy and he could lose his job. 3 marks in a bag. And then we got another one. Describe 2 ways Hamish can help prevent unauthorized access to his laptop. Easy one, we use this every day. Password, 1 mark. Why? Because you get no access without a password. 2 marks in a bag. What else do we have every day? We're getting more. What do we have every day? We still see them. Physical security. So that people cannot physically access the laptop. So physical security could be in the form of like security guards. Yes, they're still about. Okay. Or, increasingly, we're having biometrics. So it's basically fingerprints. So you can have password, no access via a password, or you can have biometrics, need a fingerprint to access. 4 marks in a bag. Or you could have 2-step authentication, which is increasingly being used, like sending code to a mobile phone. Okay, so if unauthorized access does occur, Hamish would like to use encryption to add another layer of protection on his documents. So how would encryption help in that matter? So the way encryption would help, it would use an algorithm to scramble up the data. That is 2 marks right there. That's what encryption does. We're scrambling up the data into ciphertext. So one encryption cipher is the Caesar cipher. So it's moving each letter of the alphabet 1 place to the right. Phoneme table shows the letters in the first row and the new letters in the second. So instead of having hello, we're having IFMMP. The pseudocode takes the string of uppercase letters as input, uses the Caesar cipher algorithm to encrypt it. So we're using the algorithm described in the table. ASCII, returning the ASCII value. Character, returning the character. Substring, we're returning the number of characters starting at the position value where 0 is the first. So what we need to do is complete the pseudocode, filling in the blanks. So we're asking us to enter a string. The new string is empty string. Message length is going to be message.length. And then it's going to be 4 count 2, message length minus 1. Okay. And then ASCII value is going to be the ASCII message.substring. And we're going to have the count in there because we're counting. Then it's going to be the ASCII value equals ASCII value plus 1 because we need to increment it by 1. And then the condition is if the value is greater than 90, then it's going to be the ASCII value equals ASCII value take away 26. And I'm just going to end it. And the new message would be new message, concatenate with the character with the ASCII value. That is 5 marks in a bag. So I've just said message length minus 1. Then I said count. Then I said plus 1. Then I said ASCII value. Then I said new message. That's our pseudocode. So an algorithm needs adapting. An extra line is needed to output the encrypted message. So we need to write line 12 to output the encrypted message. So on line 12, we're going to have output new message. Done. That's literally it. If you do quote, if you add quotations in new message, that is not going to be accepted and parentheses are not needed. If you do new message equals output new message, so if you were to do something like this, that's not going to get you a mark. This will. Or alternatively, just do print. That'll get you a mark. Okay? Question 4. Networks. So office has a LAN. The office has 4 employees who each have a laptop. The office has 1 server and 1 network printer. Office has a star network at the center. All devices are connected to the network using cables. So we need to draw devices and connections in the office star network with the devices labeled. So let's just say here we got a switch. And then let's say here we got a printer. You could just type these out, make boxes, type them out. Server. Then what we're going to have is laptop, 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 laptop. Okay? And what I'm going to do is I'm just going to annotate those. Switch. There we go. So that is a star network. Yeah, excuse my drawings. I can't draw to save my life. I can draw as well as my oldest auntie can sing. Glasses break. I know. So, anyway. That is how we would do it. That would get you a full 3 marks just by doing those drawings. So the printer can be connected to the server or to the switch, but I connect it to the switch because the switch is a device that connects the computers to get devices together into one local area network, which is why I put the printer connecting to the switch. Okay, let's move on. Describe the role of the switch in an office network, which I've alluded to already. It will connect the devices together and will receive data. Okay. In the next one, the office introduces a wireless access point to allow network access to wireless devices like our mobile phones. The office manager has noticed that the performance of the network has decreased, so we need to describe how introducing wireless access could have slowed down the network. That's because wireless transmission is lower than cabled. So the more devices that are on there, the less sufficient the bandwidth will be for users. Essentially, yeah. So wireless can be limited by interference, like walks that disrupt the signal. So think about what we use every day. You can say wireless can be limited by interference, like walls. That's going to disrupt the signal. So if I'm using my phone, I'm connecting on my Wi-Fi, and the hub or the switch, central and the wireless access point is 1 story down. Then that's going to interfere through the ceiling and the floor. Okay, next one. We need to identify 2 factors that affect the performance of a network. Bandwidth available and how many users there are. And then we need to explain what is meant by a virtual network. So virtual network is a non-physical network, and it can only access data in the users in the virtual network can only access data that's in the virtual network. So this is where the connection is secured. Employees can access the server and they can log in. So a private network will run on an existing network. So it's a non-physical network where a private network runs on a public network. That's a virtual network. Okay, 5A. IP address is linked to the website with this URL, OCR. How creative? Not. So when that is entered into a browser, the web page homepage is loaded. Describe the relationship between URL, the IP address, and a web server. So, This would be my approach. So you could say, the website is hosted on a web server. The website has an IP address. The browser sends a URL to the domain name system. 3 marks so far. URL will have a linked IP to which the DNS will find. That's 5 marks. If a DNS cannot find it, it passes a request to higher DNS, and if it's not found, we're going to have an error. IP address sent back to the browser sends a request to the web server will process the request for the website, and the web server sends a web page data to the user. Bosh, you're on the internet. Woohoo, well done, baby. But I would just say something basic just to pass the time. Website's hosted on a web server, website has an IP address, browser sends a URL to the DNS, URL will have a linked IP to which DNS will find. 5 marks in a bag. Computers access the internet using a TCP/IP protocol. So the TCP/IP model uses layers including application transport. So to explain why TCP/IP uses layers. That's because a layer can be changed without affecting other layers. That's why it uses it. Each layer will have its own purpose, basically, so it doesn't have to consider what the other layers are doing. So it can be programmed individually. Individual protocols are simpler to manage, and the different types can interface with different hardware. But if it was me, I would just say a layer can be changed without affecting the other layers. Next question. TCP/IP is one example of a protocol. We need to give the name of one appropriate protocol for each task in a table. Sending an email from one mail server to another. That's Simple Mail Transfer Protocol, or SMTP for short. Transmitting a file from a client to the server. That would be a File Transfer Protocol, or FTP for short. Viewing a website using a web browser. You can have one of two. You can have HTTPS, which is Hypertext Transfer Protocol, or you could have HTTPS, which is Hypertext Transfer Protocol Secure. Not Sigma, secure. And then we got downloading an email to your computer. You can have 2 of those. You can have Internet Message Access Protocol, or IMAP, or you can have Post Office Protocol, which is POP3. I would go for the IMAP because that's a more updated than POP3. So I would have IMAP. So what would I have? I would have first one, SMTP, second one, FTP, third one, HTTP, fourth one, IMAP. Then on number 6, Fiona is a software engineer. She was creating a new version of a computer game she released 3 years ago. Been out of date, but hey. She's considering selling the game online and not making it available physically in shops. So this is about the environment. Yes, how dare you? Okay, enough about that. We need to describe the environmental impact of Fiona's decision to do this. So let's think about the materials used to make the game's box and the CD itself. So there'd be less raw materials used in manufacture. That'd be 1 mark. There is less electrical power needed to make the physical copy. No petrol used to distribute, thereby smaller carbon footprint. That's 4 marks. And then I would say And also say fewer factory emissions. That's 5 marks. Or you could talk about the drawbacks of creating a physical copy, like increasing waste, raw materials used in manufacture, old versions will be thrown away, or it's going to use fuel to distribute, which will create emissions. That is so all we need to say in that is less raw materials used in manufacture and fewer factory emissions. That would literally get you 2 marks. I've mentioned 5 things when you don't need to, but I'm just giving you some of the alternative options. Okay, then the last one. Wow! Fiona releases her game under a proprietary license. Explain why proprietary license is more appropriate choice than open source. Well, because by using proprietary, she can sell it for a fee, so she can charge for it. And what it's going to do, with proprietary, you can protect your source code, so she can protect the source code, so it can't be copied. Whereas open source, it's free for the world. It's free for the whole world to see. It's basically saying, "Hello, I'm the code. I've been made by so and so." Yeah, it's free. Open source is free. Proprietary, you have to buy it, and the source code is protected by copyright. Okay, and that takes us to the whole of paper 1. If you're not feeling Sigma about this right now, I would watch the video again and then try a paper and see how Sigma we really are. Sigma meaning brilliant or the best, by the way. Don't ask, it's the best or all these good positive words in youth speak. But anyway, that wraps up our deep dive into paper 1 of the OCR GCSE Computer Science paper 1. Hope you found this video useful and gained those insights to help you succeed in your mock exam or real exam. If you found these useful, don't forget to hit that like button and subscribe for more content like this. Remember, practice makes perfect. Keep revising and you'll be well on your way to acing that exam, getting that good grade and getting to where you want to be in life. And by retirement, you could just sit back on your chair and go, oh, you can just chill. Other than that, I look forward to having you on the next video. Bye for now. So please be sure to hit that like. And please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which made me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a Replit link below on my programming videos. So you just click on REPL and this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click login, and once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page, so this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specializing in ICT and computer science. And I look forward to you coming to me for lessons. Goodbye for now.